A steel cage crudely welded onto the turret of a multi-million-dollar combat vehicle is not a sign of technological pride, but a desperate confession of vulnerability. In June 2026, at the Eurosatory Defense Exhibition in Paris, the French Army officially showcased the upgraded Leclerc XLR main battle tank equipped with a factory-standard anti-drone roof cage. Leading global defense analysts argue that this sudden modification highlights a brutal reality where Western armor is increasingly exposed and defenseless against $500 remote-controlled explosives. For France, the stakes could not be higher. Paris originally planned to retire its aging fleet of 200 Leclerc tanks starting in 2035 to make way for the main ground combat system, a revolutionary next-generation land platform co-developed with Germany. However, intense political and industrial disputes between the two nations have pushed the operational arrival of that joint platform back to at least 2045. With the French fleet legally bound for retirement and zero foreign replacements available, military planners face an absolute capability dead end. On paper, their only tactical salvation would be to aggressively transform this Cold War relic into a 63-ton, heavily protected beast capable of holding the line for the next 2 decades. Can a digitized frame and a metal grid shield a small fleet of 200 tanks against a swarm of mass-produced aerial weapons until 2045? Or is France gambling its entire land sovereignty on an obsolete platform? Before we go on, do you believe these retrofitted metal cages can actually save modern tanks from precision drone strikes? And tell me where you're watching from. To survive on the modern battlefield, the French main battle tank underwent a brutal and heavy physical evolution, pushing its technical limits to the absolute edge. By adding thick layers of reactive armor modules on both flanks, passive belly protection against improvised explosive devices, and the newly standard steel anti-drone grid on top, the weight of the Leclerc XLR has officially skyrocketed to an unprecedented 63 metric tons. This massive weight increase represents a direct challenge to its unique powertrain. The vehicle relies on the SACM V8X1500 hyperbar diesel engine, a highly sophisticated system that uses a small gas turbine as an ultra-high-pressure turbocharger. While this engineering marvel allows the platform to maintain a theoretical top speed of 72 kilometers per hour on roads and preserve a high power-to-weight ratio of 24 horsepower per ton, independent defense experts warn that forcing this 30-year-old engine configuration to constantly carry a 63-ton payload will accelerate component wear and trigger a severe logistical maintenance crisis over the next 2 decades. Yet, the physical transformation does not stop at protective armor. In May 2026, during live fire trials conducted by the 5th Cavalry Regiment in Abu Dhabi, France demonstrated a radical anti-drone concept using the primary weapon system itself. Instead of mounting complex and expensive radar-guided interceptors, the Leclerc XLR successfully utilized its 52 caliber CN 120-26 smoothbore main gun to neutralize low-flying aerial systems. The platform achieved this by firing the standard OFC F1 120mm high explosive fragmentation shell, which expels 1,100 heavy tungsten carbide pellets at a muzzle velocity of 1,410 meters per second, effectively creating a massive traveling wall of metal shards to shred incoming threats. Beyond the mechanical evolution of its heavy chassis, the true operational lethality of the Leclerc XLR lies deep within its fourth-generation digital brain. Under the ambitious Scorpion modernization program, the French Army has transformed this isolated combat vehicle into a fully networked tactical node. The core of this digital revolution is the Scorpion Information Combat System, paired seamlessly with the newly deployed Thales contact software-defined radio. This advanced architecture enables a doctrine known as collaborative combat. Rather than operating in isolation, a Leclerc XLR continuously shares telemetry, threat coordinates, and targeting data in real time with forward-deployed platforms like the Jaguar reconnaissance vehicle and airborne surveillance drones. For the three-person crew, this means they can engage a hostile target hidden entirely behind terrain or buildings without even establishing direct line of sight. The tank rotates its turret, utilizes its unique Western autoloader to chamber a round in seconds, and fires at a rapid rate of 9 rounds per minute based entirely on digital coordinates fed by a remote scout. This level of network integration provides total national autonomy, ensuring France remains completely independent of foreign software or technical permissions from other global powers. However, this dense digital framework also conceals a critical operational blind spot. Military observers note that while advanced active protection radars can detect and track incoming anti-tank missiles on horizontal trajectories, they suffer from a severe 90-degree vertical blind zone directly above the turret. Because cheap, mass-produced first-person view drones are frequently programmed to plunge straight down onto the thinnest top armor, the French Army was forced to accept a primitive physical compromise. The installation of the basic metal grid on top of a highly computerized platform is a stark acknowledgement that million-dollar digital networks remain deeply vulnerable to low-cost aerial threats. The reliance on this updated version of the Leclerc XLR until 2045 exposes a profound strategic fragmentation within Europe. The collapse of joint projects and the delay of the future land combat system prove that a unified continental tank standard no longer exists. While Germany aggressively markets its Leopard 2A8 and Eastern European nations secure massive contracts for South Korean equipment, France stands entirely alone with its small fleet of 200 highly customized platforms. This long-term commitment to an older chassis incurs an enormous financial penalty that ripples far beyond the European continent. Funding the complex maintenance of a 30-year-old heavy engine and producing custom ammunition like the OFC F1 requires hundreds of millions of euros. According to regional defense studies, this sustained financial drain directly restricts the procurement budget of the French Navy. Consequently, Paris will likely be forced to reduce the deployment frequency of its naval task forces, including the Charles de Gaulle aircraft carrier, in vital international waters. This budgetary restriction directly dilutes the strategic footprint of France across the critical Indo Pacific theater over the next 2 decades. Ultimately, the survival of the Leclerc XLR offers a vital lesson for modern defense planning. True sovereignty is not just about designing the most advanced digital network, but about the industrial capacity to mass-produce platforms before older fleets face absolute obsolescence. France has successfully engineered a heavy mechanical masterpiece, but it remains a defensive compromise born out of industrial isolation. If a sudden geopolitical crisis erupts, 200 highly sophisticated platforms may simply not be enough to hold a shifting front line. Can a limited fleet of heavily upgraded Cold War tanks truly safeguard national sovereignty in an era dominated by cheap, autonomous warfare? Or has Paris miscalculated the real cost of military independence? Turn on your thoughts in the comments section below.